homologous series used for a variety of purposes in everyday life. State what is meant by the term homologous series. A homologous series is a family of compounds with the same general formula and similar chemical properties. Alcohols can be classified depending on how many hydrogen atoms are attached to the carbon atom bonded to the functional group. The carbon atom is circled in the example shown. Name the functional group present in all alcohols. So an alcohol is a covalent molecule which contains the functional group known as the hydroxyl group. Written 10b, alcohols can be classified depending on how many hydrogen atoms are attached to the carbon atom bonded to the functional group. This carbon atom is circled and the examples are shown. So if we look at the first example, the classification is primary and we can see that it has 2 hydrogen atoms attached. The second one is known as secondary and we can see that the carbon atom has 1 hydrogen attached. Tertiary has 0 hydrogens attached. So if we look at the carbon which contains the hydroxyl group, we can see that it only has 1 hydrogen atom attached, therefore it would be classified as a secondary alcohol. Written 10b part 3, draw an isomer of 3-methyl-butanol which has a different alcohol classification. So remember that an isomer has the same molecular formula but a different structural formula. So to do this, the easiest way would be to change the position of the hydroxyl group onto position 1, which would give it a primary alcohol classification, but here are all the potential answers that you could have. Written 11a part 1. The Screaming Jelly Baby is a popular chemistry demonstration where the sugars in a jelly baby react with oxygen. In the demonstration, potassium chlorate, KClO3, is first heated in a boiling tube until it decomposes, producing oxygen gas. The balanced equation is given. Describe how you could test for the presence of oxygen. So this is one of the gas tests that we need to know, and to test for oxygen, it relights a glowing splint. Written 11a part 2, write the formula for potassium chlorate, KClO3, showing the charge on both ions. Remember, the ionic formula is usually formed between a metal and a non-metal ion. If we take potassium, which is a metal, it's found in group 1, so it would want to lose 1 electron to form a positive ion. The ClO3, which is the non-metal part, the formula for that will be together, and because the charges have to balance, it means that the charge on the chlorate has to be negative. 11b, the jelly baby is then added to the reaction mixture. The sugars in the jelly baby undergo an exothermic reaction with oxygen. State what is meant by the term exothermic. So exit comes from exit, thermic to do with heat. So we need to know that that is a reaction that releases or gives off heat energy. 11b part 2. During the demonstration, brightly coloured flames are produced. Suggest why the flames are lilac coloured. So what we want to do is we want to use our data booklet to look up the flame colours. We know that the metal which is found in the product is potassium. So if we look that up, we can see that potassium has a lilac flame colour. Written 11c, the equation for the reaction of sugar glucose is shown, and asks you to calculate the mass in grams of oxygen required to react completely with 2.25 grams of glucose, which the formula is given as C6H12O6. So the first thing you want to do is pick out your entities. So we're working with glucose and oxygen. We then take our mole ratio from the balanced chemical equation. We've got 1 mole of our glucose and we've got 6 moles of our oxygen. We then want to times through by the GFM, and if we work out the GFM of the glucose, we've got 6 carbons times 12, which gives us 72. Hydrogen, we've got 12 times the relative atomic mass of 1, which gives us 12. Oxygen, we've got 6 atoms times the relative atomic mass of 16, which gives us 96. And when we add them up, we get a GFM of 180. For oxygen, we have 2 oxygen atoms times 16 for the relative atomic mass, which will give us a GFM of 32. And getting both GFMs correct will get you 1 mark. We then multiply those out, so 180 times 1 gives us 180 grams, and 6 times 32 gives us 192 grams. That will get you your second mark. We then have to scale. So we have been given in the question 2.25 grams of glucose. We put the same unit same side and then we cross multiply. So we'll pop in our calculator, 192 times 2.25 divided by 180, and the answer comes out at 2.4 grams, which gives us our third and final mark. Written 12A, Part 1. The covalent radius is a measurement used to indicate the size of an atom. The diagram below shows the covalent radius for elements in groups 1 to 7 of the periodic table. Describe the trend in covalent radius going from sodium to chlorine. So using the numbers given in the table going from left to right, we can see that the covalent radius decreases. Written 12A, Part 2, describe the general trend in covalent radius going down a group in the periodic table. So if we take the first group, group 1 of the periodic table, we can see from hydrogen to rubidium that the covalent radius increases. Written 12A, Part 3, predict a value in pictometers for the covalent radius of strontium. So what we do is we take group 2, which has strontium at the bottom and beryllium at the top. The difference between beryllium and magnesium is 41, and the difference between magnesium and calcium is 34. So we can see that that's decreasing. The change between those two numbers, however, is 7. So we want to copy that trend as we've got no value given for the covalent radius of strontium. So if we say that the change between calcium and strontium is take away 7, we would say that the change between the calcium and the strontium would be 27. What we can see there is the trend of the covalent radius is actually increasing. So if we add 27 to 174, we get a value of 201. The range given by the SQA is between 175 and 214 pictometers. 12B, the covalent radius is defined as being half the distance between two bonded nuclei. We can see in the diagram here, we've got the distance between the two nuclei and it's shown halfway we have the covalent radius. It says calculate the distance in pictometers between the nuclei in bromine. So if we use the table given, we can see that the value given is 117. So if the covalent radius, that's half of the distance 117, the other half's got to be the same as it's the same element, which is 117. So 117 plus 117 gives us 234 pictometers. 12C, Part 1. The radius of the sodium ion Na+ is smaller than the radius of the sodium atom. Write the electron arrangement for the sodium ion Na+. You may wish to use your data booklet to help you. So the sodium atom would be 281. However, we want the sodium ion. It wants to lose one electron to achieve stability, to have a full stable outer electron shell. So the electron arrangement of the sodium ion is 2,8. Part 2 to this question suggests why the radius of a sodium ion is smaller than the radius of a sodium atom. Now, if we look at the electron arrangement of a sodium atom, it has the electron arrangement 281. We can see that it has one outer electron, and all elements want to achieve stability by having a full stable outer electron shell, so it wants to lose that one electron. The sodium ion would then have the electron arrangement 2,8. So what we can see there is that it has one fewer electron shell.